Alright, boys and girls. Today we're going to go through and do translation, which is essentially the culmination of everything you've done the last 2 or 3 units. I am going to give you a word version of a chemical formula, and from there you're going to go through and you are going to tell me specifically what the chemical formulas and symbols and signs need to be to create that chemical formula. Tell me the type of reaction, and tell me if that reaction is balanced or not. We are not balancing here because that would be kind of unfair. If you screw up the translation, then you would obviously screw up the is it balanced or not. So we figure one step at a time. Anyways, from here you need to go through and kind of keep track of, is it ionic, is it covalent? Because again, those namings and going from name to formula are going to be different. And kind of keep track of diatomic molecules, because diatomics are going to have different symbols than regular atoms. Anyways, from there we'll start off. Aluminum, we're going to end up having Al, not diatomic, so I don't put a 2. And it's going to be a plus. Hydrochloric acid, and because you haven't seen that before, I tell you that is HCl. React to form, boop, there's going to be a nice little arrow. And you're forming aluminum chloride. Now this is, again, this guy is a metal, this is a non-metal, meaning this is ionic. So in order to find the chemical formula, I need to actually figure out oxidation numbers. I know this is a +3, and chlorine's a -1. When I end up crisscrossing them, I'll end up with a AlCl3. So don't forget the oxidation numbers and the crisscrossing if it's ionic like this is. And hydrogen gas. Now, a big key here is we know that hydrogen happens to be diatomic, so we know it's going to be H2. Now, from here, we got to go through and figure out the type of reaction. I have a lonely aluminum over here, a lonely hydrogen over here, so this is going to end up being single displacement. And with this single displacement, I know that it is not balanced because every single thing on this left side happens to end up being one atom. I have 3 chlorines and 2 hydrogens over here, so it is not balanced. If you wanted to balance it, you would go through, throw a 3 here. Now your chlorines are balanced. However, I know that I can't go through and get this guy. I throw a 1.5 here. Now, this is perfectly balanced, but impossible. So in order to fix that, we would go through and we would double everything and turn this invisible 1 into a 2, turn this into a 6, turn this invisible 1 into a 2, and turn this invisible, or 1.5, into a 3. So your balanced reaction would be 2, 6, 2, 3, 2 aluminums, 6 chlorines, 6 hydrogens. Anyways, moving on to the next one. Phosphorus mixes with oxygen gas to produce diphosphorus trioxide. So looking at this, I start off with phosphorus, P. This is not diatomic, so I don't have to worry about subscripts. Mixes with is a nice little plus. Oxygen gas, O2. Remember, this is diatomic, so I'm keeping the 2. To produce diphosphorus trioxide. Remember, the di and the tri tell us this is covalent, so I've got P2O3. In terms of setting this whole thing up, type of reaction, we're going to have synthesis. In terms of is it balanced? Of course not. I've got 2 phosphori over here and 3 oxygen, only 1 phosphori and 2 oxygen here, so again, not balanced. Very few of them are. And if I were to go through and balance this whole thing, we want to take the oxygen and find the lowest common denominator between the 3 and the 2, which is going to be 6. So multiply that by 3, multiply that by 2. Now my phosphorus is set up at 4. A nice little 4, 3, 2. Should go through and balance this. Again, you do not have to be able to balance these, but practice never hurts. So, moving on to our next one, number 5. We've got selenium hexachloride and oxygen gas react to form selenium dioxide and chlorine gas. So we're going to start this off. Selenium and hexachloride. I know this hexa tells us that we've got a covalent, so we're going to have SeCl6. And, nice little plus, oxygen gas. Remember, oxygen is one of our 7 diatomics. They're going to react, nice little arrow, to form selenium dioxide dioxide, 2 oxygens, and chlorine gas, Cl2. And remember, we've got a 2 because chlorine is one of our 7 diatomics. So from here, type of reaction, aluminum or oxygen's lonely, chlorine's lonely, so we're going to end up having a single replacement. Is it balanced? Of course not. I've got the equal number of oxygens, but my chlorines, I've only got 2 chlorines here. I've got 6 chlorines here. So if I were, by some magical act of God, to go through and balance this thing, I believe a nice little 3 here turns my chlorines into 6, chlorines into 6, selenium's 1 and 1, oxygen's 2 and 2, so that nice little 3 balances this whole thing. Moving on to number 6, we start seeing numbers in our equations, which means we're obviously talking about ionic bonds that happen to have transition metals involved. So let's get into this guy. Calcium oxide mixes with manganese 4 iodide to produce manganese 2 oxide and calcium iodide. Lots of compounds going on here, so I'm already thinking double displacement. Anyways, calcium oxide, I know that calcium's a +2 and this is a -2. Again, metal and non-metal, so we gotta use the oxidation numbers. So we're gonna end up with a CaO. Mixes with manganese 4 +4, and iodide is going to be a -1, so I've got MnI4 to produce manganese 2 oxide. I've got a 2 here, oxygen is going to be a -2, so I'm going to end up with MnO, and calcium iodide. Calcium is going to be a +2, iodide's a -1, so we get a CaI2. In terms of translation, again, just double check. We know that metal, ionic, you know that the transition metals happen to be ionic because, again, they're metals, and calcium, ionic. So because they're ionic, we're using the oxidation numbers to figure out the actual chemical formulas. So from here, switching up, type of reaction, we're talking double displacement. There are compounds and 2 compounds on each side. And again, displacement or replacement, the same thing. You can use either term. And then, is it balanced? No, it is not balanced. In terms of balancing the setup, I know that this has 4 iodines and this has 2 iodines. So we're talking not balanced. Let's keep moving our way through. Number 7, we've got aluminum bromide going through and bonding with chlorine gas, and they react to form an aluminum chloride and a bromine gas. Awesome. So aluminum, again, I know it's a metal, so we're talking ionic, +3, bromide's a -1, so I'll have AlBr3, and chlorine gas, and remember chlorine gas is diatomic, so we've got Cl2, and they react to form aluminum chloride. Again, aluminum's a +3, chloride's a -1, and this thing is ionic because we've got that metal there. So AlCl3, and bromine gas, Br. And remember, if we're talking Brinkelhoff, bromine is one of our 7 diatomics, so that's going to be Br2. In terms of type of reaction, chlorine and bromine are going to be the single displacement parts. So we've got single displacement. And the is it balanced? I've got 2 bromines here, 3 bromines here, not balanced. 2 chlorines, 3 chlorines. So again, no, it's not balanced. Moving on to number 8, our final translation question. We've got potassium metal and chlorine gas combining to form potassium chloride. So I know potassium metal, just simply a K. And we know it's not part of Brinkelhoff, so I don't even have to worry about your diatomic 2. It's just a plain K. And chlorine gas is a diatomic, however, so we've got to keep our Cl2. Combine to form potassium chloride. Now I know potassium's a metal, chlorine's a non-metal, which means I got to figure out the oxidation numbers. +1, -1. End up doing our crisscross here, so I've got KCl. In terms of types of reactions, we're talking synthesis. And in terms of is it balanced? No, it is not balanced, simply because we have 2 CLs over here and 1 CL here. If I dropped a 2 here, our CLs are now balanced, but we got to figure out what that's going to do. So I now have to put a 2 in front of that guy. And we end up being balanced at 2, 1, 2. Okay. Hope this helped out with translation. If it didn't, obviously there's more practice available with the extra help pages on the website.